All right, Lady Ada, what is this?
Hey everybody, and welcome to Show and Tell. We're back hosting, the OG host, me, Lady Ada, with me, Mr. Lady Ada. Sometimes we have other people come by and host for us, maybe next week. But for this week, we're going to check in with some people around the maker community. What are they 3D printing, blinking, singing, chip tuning, etc. We got some other people coming in. It looks like it's going to be a packed show, so that's awesome.
We're here every single week. Next week, little programming note, it will not be on Wednesday, it'll be on Friday because it's CircuitPython Day. So come on by Friday at 7:30 p.m. Eastern, or if you record a video, you can let us know. We'll probably be able to play it some way. Doesn't have to be a Python on hardware related project, but it happens to be CircuitPython Day, so come on by. First up, Jay, how you doing? What you building? What you making? What's going on?
I got this.
Ooh, there you go.
There we go.
Is this one of those UAPs that I keep seeing on the news that the Pentagon is hiding from everybody?
I don't know what any of that is, so I'm going to say no.
Is this
something I'm just working on? I'm trying to get the AI working now, so I'm not really. I've been programming all day, so I haven't even seen the sun. But yeah, right now I'm just using basic facial recognition and then waiting for the AI API stuff to get together, which has been driving me insane.
Yeah. I like that this is emotional support robot. That's cute.
Yeah. It's a horrible emotional support robot because it's causing me my most stress right now.
I was going to say, you need to get a robot for your robot.
No, my robot needs to do a better job.
What AI stuff are you poking at to get this to work or not work?
I have looked at a few today, and I've tried like 3, and I've got none of them working. So we're at that point now. We're at that fun part of this. There's so many chefs in the kitchen. I don't know who to work with at this point.
I know. I've been there. It's a tough place, but like you're gonna find something. Something will come together.
Yeah, we have this Braincraft hat that like you could do video. It could do recognition, moving around stuff, and like face recognition, and then getting all this stuff together was pretty hard. So good luck. Do you want to come back maybe next week or so with some updates?
We'll see what happens. I make no promises because when it comes to programming, that's the hardest thing for me.
Yeah.
It takes so much time and patience that I'm not built to have.
Are you telling me you can't just type it in ChatGPT and it spits out perfect code? I thought that's what
they don't. That's a myth. That's mythology.
I thought that's how it worked. You just say, "Give me all the code," and it just does it for you.
No, that's not how that works. I wish it was how that works, but until then, no, that's not how that works. I am just.
Well, the mechanical looks really good.
Yeah, it's a fun looking robot. All right, well, keep coming back, Jay, and yeah, good luck on it.
I want to give you emotional support. We're there with you.
Thanks.
All right, next, hey Scott, what you building? What you working on? What's going on?
Hello. Let me share a screen. I just turned stuff off. Actually, you can leave me there. Let me show you what I'm working on. Okay. This is an upside down 1170 EVK board. This is like a super fast IMX RT. And what I've been doing is I've been adding better IMX RT support for Blackmagic, which is the thing that gets used with this is an Orb Trace Mini. So Blackmagic is open source kind of debugger firmware, and I'm adding the ability to detect and hopefully flash other IMX boards. So if I share screen quickly, I think
as soon as I see it.
Yeah, I'm trying to. Maybe I have multiple terminal windows. Yeah, so this has 2 things here. So this is GDB here. So you do Mon S to do a scan, and you can see that it is detecting that there's an 1176 there. And then this is the Blackmagic software down here, and it's trying to enable the flash stuff, but unfortunately, it's not actually reading the flash correctly. So I've got detection working for the 1176, but I don't have the flashing working. That's okay, and I'll PR it tomorrow. But I did get the rest of the stack of boards.
Yeah, boards.
IMX RT boards going. So the 1011 will be supported. That was the main reason I did this, because the 1011 is a little bit different than what they had, the existing support they had. So I did that. And then I know you have a lot of people, but I did show this off as well. I got the PCB PCByte probe things, and these probes always fall when I move it. But it's pretty neat.
LK99 over there.
I haven't looked at that stuff yet. I haven't followed the LK99
levitating. So that's what for folks who don't know, that's when you need to do some type of specific testing.
Yeah, so it has these like little pogo pin springs so that you can just like place it on your board, and it in theory stays there. Obviously it's not stable enough if you move it around, but it does have this like pretty satisfying weight to it if you're willing to have them like come from the top.
That's nice.
So it's almost like a third hand thing, but they're like they're probes or pogo.
Yeah, and you can get like these are just the logic analyzer probes, but you can get ones that are like 100 megahertz or 500 megahertz worthy as well for using with an oscilloscope.
That's nice. I hate trying to hold.
Yeah, because I'm sure we have the kind of twisty, and that you can get things in place.
I have some of those.
You have to wrap the probes around it to
yeah, they're super annoying. And like the fact that these are pogo pins is really nice. Like
that is nice.
It like you don't have to get the positioning exact because it has some give. And then these are super cool because you can push
move them around,
this down to give you to like slide the board in and stuff. So it is like the board itself is like super sturdy, and the probes work pretty well as long as you're not moving it to show it on show.
No, that looks great.
Okay,
Perfect.
and then happy Circuit Python Day in advance.
Thank you. Yeah,
this is one of your jams. So you're going to be doing some stuff on Friday of next week.
Yeah, so I'll be deep diving this Friday at the normal 2 p.m. and then next Friday I will be deep diving at 2:30 p.m. Pacific.
Okay.
Because there's so much going on that day. That's the slot that I'm fitting in.
Okay. All right. Well, we'll see you next week. So thanks so much.
Thanks
a lot. Good to chat with you.
Next, JP, what you got going on?
Hey, I have a little cute build I did for my product pick yesterday, which was this little TRRS 3.5 millimeter stereo cable adapter, little breakout. And to demonstrate it, I built a little Altoid tin project, which I haven't done in a while. And man, I forgot how satisfying it is to make something that just fits so nicely in a little Altoid tin. This is one of the little mini mint tins, and we have a permaproto that Lamar designed just for that. So this was kind of a fun little build I did to show this thing off. And what I'm doing with it is the demo here is that I'm using it to take in USB MIDI information and spit out serial UART MIDI information, which works really well as kind of a standard now in sense of using these types of TRRS cables to do that. So I demoed it on a different synth yesterday, but this is a cute little Korg, like $100 synthesizer that has this horrible little touch strip. I mean, it's a fine touch strip, but you're not going to play much of interest with that. But you can feed MIDI into it. So if I plug my little MIDI gizmo in here, I can then send either MIDI directly from the QT Py, or in this case, I'm going to send it coming out of another program that's sending a cute little MIDI song. And then I am free to like mess around with picking different oscillators for this and massaging the which is the fun part, twiddling knobs and getting it to sound cool, at least for me, much better than me just trying to play a dumb melody on there.
I love how it's like a 7 segment. They couldn't even get like a alphanumeric, it's so cheap.
Yeah, so you have to do these like impossible to understand what they're trying to write 7 segment things.
Altoid cases are still the like maker mainstay. It's been 20 years.
Yeah, they're pretty great for this sort of thing.
They still have a place.
So yeah, that's just a little demo project I did. And these kinds of things are, they exist. You can go and buy a thing that'll turn USB MIDI into serial MIDI. But one of the things that you often see people asking about is, hey, I kind of want to massage that data before it gets to synth X. So if you want to translate some message into another format, if you want to tell it to send different patches at different points, if you want to shift the key to a different key, being able to write that stuff in CircuitPython is actually kind of great. And so that's the promise of doing a project like this instead of just buying a thing off the shelf, is that you can make it be what you want. So that's my little cute.
All right. Well, thanks so much, JP. You're doing your show tomorrow, and then next week you're also going to do
Yeah.
Some Python Day stuff, right?
Yeah, a bunch of CircuitPython Day stuff. So I'll see you all there.
All right. Thanks so much, JP. All right, Liz, what you got going on this week?
Hello. So I sent some parts to get CNC milled from JLC PCB. So one of the parts I did was Lego brick. This was Nay's design that he CNC'd himself, and it does work. We have Gonzo the Great on top.
It
fits nicely. So one thing that's cool about the JLC is that you can get it anodized. So this was anodized with the blue, and I did the matte, and then the bigger star though was I did the 4x4 MIDI controller about a week ago, and I got the case milled. So I did black for the panel, and you can see the Adafruit logo came out really nice. And then I did pink for the underneath. I was hoping it would be a little bit more like kind of fluorescent, but it's more like a rose pink, but it's still pretty.
Yeah, it looks like the Apple like like laptop pink.
Yes.
So that's like one
it's business pink.
That's two solid chunks of aluminum.
So this is so I can just get screwed in. I'll show what the design is. It's like this kind of hollowed out case with standoffs for the 1x4 rotary encoders, and then it has a front panel. So this was a 3D printed version, and then for aluminum it looks the same. I actually didn't have to change out the CAD or anything. I just uploaded the files as I had them. So it's hollow inside, and it has the standoffs, and then the cutouts for MIDI and USB, and the mounting holes for the feather doubler too.
Huh.
So
that's really nice.
Looks nice.
Yeah, I'm really pleased with it. And especially with this one, I'm using it with a guitar pedal, so now I can kind of have it with my setup and not have to worry about crushing it.
We were just talking about this. This is the best time to do electronics and be a maker. You don't need to have a 3D printer physically. You don't have to go somewhere and mill stuff. All these services are starting to become available, low cost enough. Sometimes it's even faster to send it out to get made and have it come back than printing it yourself. So you could potentially, someone could go to the Adafruit learning system, get the electronics, or it's open source, you can make their own whatever. But you could build everything and have everything come together. Before there was always like, oh, if I only had a 3D printer, if I only had this, I only had that. That's really cool. Okay.
Yeah. So I was really pleased with it. So I'll share some photos, folks, and but yeah.
Okay,
nice
and then happy CircuitPython Day in advance. Maybe we'll see you next week doing some stuff.
Yes, I'll be joining Nay and Pedro on 3D Hangouts, so we'll talk about some of our collabs we've done with CircuitPython projects.
Right. Okay, thanks so much, Liz.
Thanks, Liz.
All right,
all right, Maker Melissa, what you got going on this week?
I've been working on this sign. I kind of showed it off last week, but I have improved it a lot. One of the things I've done is I have taken the alpha blend function in CircuitPython's bitmap tools, and I've added some improvements to it, such as like some masking, and I've worked on the formula that does the algorithm rather that does the blending here. And I just tried to hook it up with these buttons here so you could change the opacity in real time. Just to kind of show how it's going over a background and just blending it in real time. And then I added a little double buffer thing to it to make it smooth. And I think it's looking pretty good.
Yeah, that looks like very smooth animation.
And then next week you're doing a CircuitPython Day project online with the world. It's a portal project, right? You're going to show people how to use it.
Yep.
Okay, right on. Well, thanks for doing that. And thanks for coming by, showing the updates on this project and more. And we'll see you next week.
Yep. Thank you.
Yay.
Thanks. All right, we're going to go to Bob, then Brandon, and then Micha. Bob, what you got going on?
Hey, I showed you guys briefly the keyboard resistor logging, and I just kind of want to finish that. So I'm going to share my screen. Screen one here. Wow. Okay, you see my screen?
Yep.
Okay, so I've got a keyboard already done here. I decided to go with 0.5% resistors, give me 50 part per million Tempco, so I could get 34 keys. And the one thing that I didn't get to last time is, so now you have a hardware design, and that's all well and good. but you got software to write to read this thing. So I wrote a code generator in XOJO, and so what it gives you is commented all the limits in A to D and voltage levels, a kind of rough pictorial schematic and text, and the binary search for the key, and a little routine you can call to read your key.
Nice.
So you get both the hardware and the software. And then the other thing you have to do, if I can hit stop screen here, is the next thing, you got a product that's done and you have to simulate it. So you just take a programmable power supply. I'm going to show you with my Pocket Frog here. And you put in a sequence of the voltages that your keyboard represents. And I just have a calculation I dropped in that gave a sequence of keys. And if I drag this over on my screen, now, if I drag my scope over, these are the voltages of a key. This is the rest voltage for the keyboard. And you just have a test sequence you can run as long as you want. So it just kind of gives you both a keyboard and an easy way to simulate and get a product tested for market.
I love that how you just took the project and you just took it as far as possible. Like you're like, not only will I give you the math and the entire like temperature range, and I will give you a schematic, and I'll give you the code, and I'll give you the test sequence. So anyone can duplicate your work, which is cool. It's not common that electrical engineers do really good documentation, so I'm impressed. And I don't know if here I can say
Thank you. Okay, and if I got another 10 seconds,
yeah,
I shot the link up to my website. If anybody's ever played with FTDI serial ports, they're all over. They're pretty cheap. And they just make a sequence of pulses. So I wrote a little program. You can also download this off my website, where FTDI parts actually support arbitrary baud rates. So I go through and do the math, and you can turn a serial port into a poor man's pulse generator. And if you get the RS-485 versions that are a couple bucks more, you get both positive and negative pulses.
Yeah.
So that's all he is.
It's quite a hack. All right, cool. All right, yeah, drop
Thanks so much,
link
Rob.
to your website.
And thank you for sending the links and more along. It's getting blogged up on Adafruit.
Thank you.
Thanks, Bob.
All right. Next, Brandon, how's it going? What you got going on this week?
Hey, doing well. So probably about a year ago, I created this little guy. It's it's 310 LEDs because everybody likes LEDs. But it's really kind of cool. It's got a simple Lawlin S2 Mini on the back, and when I sell this, I ship it with CircuitPython and some libraries, and I also provide a helper library for controlling all these. And it was kind of interesting. People liked it and stuff, but it wasn't the most convenient shape. And so I created a very similar one, which has got 280 LEDs. And focusing on performance, this is all in parallel instead of just one big long series. And I got wind from a couple of DJs that do the various conferences that they were using this with a piece of software called Sensory Bridge. And Sensory Bridge is actually a product that Lixie Labs sells on Tindy, but they publish all their source under MIT. So mostly what I'm talking about tonight is I love groups and people that publish open source under very open,
Hey.
and so I said, well, we've got these conferences going. It'd be really kind of cool if I could take their sensor bridge, which also runs on an S2 chip, and port it to this little guy. And so I said, well, I looked at my PCB and I realized I don't do anything out here. So I literally took one of these and ground it down to a circle and put a little LiPo charger on it. It's about 3/4 of an inch thick. and I'm running the sensory bridge software on it. And it's got all the functionality that a sensory bridge does, but it's completely portable, and you can wear it with a lanyard like everybody else does. And so a quick little demo here. I had to find some open source music that I could play, so you might recognize this. It's got a little mode button on the back, so I can change the mode. So here's a sort of like sweeping mode that they do. And again, this is
DJ. Actually reminds me of like 1990s like car stereos.
Yeah.
You know?
What amazed me is they put so much work into the code. Even on an S2, they're running in excess of 120 frames per second, doing both the audio processing using a MEMS microphone and the LED updates. When you spec this out, it typically runs around 130 frames a second is what it's able to update. And so they just went crazy with the optimization of their code. And they're wonderful developers. And so I wanted to just simply show that open source can be really kind of cool for people, and you can port it to stuff and run it on stuff. And so I actually found out there's 2 DJs running this at a conference right out in Vegas this week on multiple devices. And the next conference I go to, I'm going to be wearing it.
Yeah. All right. It's definitely hacker summer camp season. So
it is definitely hacker summer camp season. So yeah. So a quick shout out. Lixie Labs is a company that creates the sensory bridge, and they write their software and they put it out under the MIT license. Some folks.
Cool.
Outstanding. Yay. All right. Thank you so much. And keep coming by and showing and sharing not only this, but, giving some, we call them hug reports, giving some kudos to the folks out there sharing stuff so other people can build upon it and more.
Thank you.
Thank you.
Thank you.
All right. Micah, play us out.
Hello. So I've shared a few updates on this. It's called the eFidget. It's my haptic feedback fidget spinner, or fidget toy, or whatever. It's been a very long saga, and I've come a long way. This is the eFidget Lite version 1, and it uses a relay with the goal of having that give a nice click for haptic feedback. And the idea was when you press and hold the button, or you can like tap out a rhythm on it, and it'll copy that on the relay. The relay was really, really noisy and did not have a satisfying click. And on top of that, I downloaded a footprint from like SnapEDA or whatever. And the footprint didn't have the correct net set up for the plus and minus of the battery. So it actually had as you can see here, there's two pins for the plus. So it had both of those connected to. It had one of them connected to plus, one of them connected to minus, so it didn't work. And I tried to rework it, and it was just a mess. So I went on to eFidget Lite version 2, which I have here, and it's actually working really well. So this is an LRA vibration motor, so linear resonant actuator, and it's actually from a company that I discovered from Ion NPI about a month ago, and it's not the same one, but it's same company. And I've got the same microcontroller, ATtiny13A button, and when you press and hold the button, I mean, obviously you can't feel it, but
they feel great. They have a nice clicking feel.
Yeah, when you press and hold the button, it clicks, I'd say about 3 times a second, maybe a little more. And it's a great little fidget. I have it powered off of a CR2032 battery, and I just, like maybe an hour ago, got it to use so little current that I calculated it, and with a rough calculation, it said it should last about 30 years if you're not using it.
That's great.
Yeah, so I mean,
congratulations.
What? Sorry?
Congratulations on your success.
Thank you so much. I really appreciate it.
Yay! You didn't let the first version you. Just important.
Yeah, this is tech 5 of the eFidget.
All right.
So, it's eFidget Lite. Yeah. Sorry, it's the eFidget Lite version 2, but it's version 5 in general.
Well, thanks for sharing the journey of this fidget.
Of course. Thank you so much for having me.
All right. Well, keep coming by, and thank you so much, everyone.
Okay.
That's the show and tell the week of this week. Thank you so much for joining us. We're usually here every Wednesday, 7:30 p.m. Eastern Time. Next week, however, it's going to be Friday at 7:30 p.m. Eastern Time because it's CircuitPython Day. But you can assume that usually, unless it's CircuitPython weekday, Wednesdays, 7:30. Come by, retro hardware, cool stuff you've seen, books, you name it.
Sharing, doing,
share it,
showing.
Things under cool licenses that allow you to build more and share more. All of that stuff is welcome. We'll see everybody next week, Friday at 7:30 p.m. for special edition show and tell. You don't have to show a Python enabled or powered project.
But if you had one,
but that's the theme. But come on by either way, it doesn't matter. And we'll see everybody next week. See you soon. Ask an Engineer starts in a couple minutes. Bye bye.